Sensors and actuators, the unsung heroes of modern life. Have you ever wondered how your smartphone knows when to rotate the screen or how a self-driving car navigates the roads? Well, the answer lies in the incredible world of sensors and actuators, two fundamental components that breathe life into modern technology. These often overlooked heroes are the silent partners that make our devices smart, responsive, and capable of interacting with the world around them. Think of sensors as the eyes and ears of electronic devices. They are designed to perceive and measure various physical properties such as temperature, light, pressure, and motion. Actuators, on the other hand, are the muscles and limbs responsible for converting electrical signals into physical actions, enabling devices to move, make sounds, or control other systems. From the simplest household appliances to the most sophisticated industrial robots, sensors and actuators work in perfect harmony, forming the backbone of countless technological marvels we rely on every day. Sensors are the unsung heroes that bridge the gap between the physical world and the realm of electronics. They act as the sensory organs of electronic devices, allowing them to perceive and measure various physical phenomena. In essence, sensors translate real-world stimuli into electrical signals that can be understood and processed by electronic circuits. Imagine a simple temperature sensor. This tiny device contains materials that change their electrical properties based on the surrounding temperature. As the temperature rises, the electrical resistance of the sensor might decrease, and vice versa. By measuring this change in resistance, the sensor can accurately determine the temperature and relay this information to a connected device. The world of sensors is incredibly diverse, with each type specializing in detecting a particular physical property. Let's shed light on a few examples. Light sensors. These sensors, commonly found in smartphones and automatic lights, measure light intensity. They work by converting light particles or photons into electrical signals, allowing devices to adjust screen brightness or turn lights on and off automatically. Proximity sensors. These sensors detect the presence of nearby objects without physical contact. Smartphones utilize them to disable the touchscreen during calls, preventing accidental touches. And motion sensors. These sensors detect movement and changes in position. They're used in security systems to detect intruders and in gaming consoles to track player movements. Section 4. Actuators, bringing technology to life. While sensors act as the senses, actuators are the muscles and limbs of electronic systems. They are the components that bring technology to life by converting electrical signals into physical actions. Think of an electric motor, a common type of actuator. When an electrical current flows through the motor's coils, it creates a magnetic field that interacts with permanent magnets within the motor. This interaction generates a rotational force or torque, causing the motor shaft to spin. Section 5. Examples of actuators powering movement and control. Actuators come in various forms, each tailored to perform specific tasks. Here are a few notable examples. First, motors. These actuators convert electrical energy into mechanical energy, producing rotational motion. They power a wide range of devices, from electric cars to robotic arms. Next, solenoids. These actuators use electromagnetic coils to generate linear motion. They are commonly found in door locks, valves, and relays, where they provide a simple and reliable means of mechanical control. And finally, servos. These actuators are essentially motors with built-in control circuits, allowing for precise positioning. They are used in robotics, animatronics, and other applications requiring accurate and repeatable movements. Section 6. Sensors and actuators in harmony, a symphony of technology. Sensors and actuators rarely work in isolation. Instead, they collaborate seamlessly, forming intricate feedback loops that enable intelligent and responsive systems. This collaboration is orchestrated by a microcontroller, a tiny computer that acts as the brain of the operation. Let's consider a simple example. An automatic door. A motion sensor detects the presence of a person approaching the door. It sends a signal to the microcontroller, which then activates an actuator, such as a motor, to open the door. Once the person has passed through, the sensor no longer detects their presence and signals the microcontroller to close the door. Section 7. Conclusion. The pervasive impact of sensors and actuators. Sensors and actuators are the unsung heroes of our technology-driven world. They are the silent partners that make our devices smart, responsive, and capable of interacting with the world around them. From the smartphones in our pockets to the self-driving cars of the future, these tiny components have revolutionized the way we live, work, and interact with technology. As technology continues to advance at an unprecedented pace, we can expect sensors and actuators to play an even more prominent role in shaping our future. They are the key enablers of the Internet of Things, where everyday objects are becoming increasingly interconnected and intelligent.